Okay, let's start today inequality part. Now last day we have done linear type inequalities and double inequalities, no? All are linear type. And also we have done quadratic type inequalities, no? Now further we have do polynomial inequalities, further polynomial inequalities and special relations under inequalities. Okay, now first of all, check this one. X square plus 1 greater than 0. X square plus 1 less than 0. Then x squared minus 1 greater than 0. So here we have solution x minus 1, x plus 1. Then corresponding inequality range minus 1 to plus 1. Here plus, minus, no? Then positive region here and here, no? X element of real set x such that x less than minus 1 union x greater than 1. Here it is, okay? But when you consider x square plus 1 greater than 0 inequality, so we know x square plus 1 always positive thing, no? X square plus 1 always positive. Then for any real value this is possible. Then solution is any real value. The solution is any real value, okay? Then when you consider x square plus 1 less than 0 thing, x square plus 1 less than 0, that won't happen. Surely x square plus 1 is positive value, no? This won't happen. Therefore, no any real value for this. No any real value for this. Okay? Then you say x square plus 1 less than 0, no real value for the inequality, no? Then fourth one, see x minus 1 square greater than 0. X minus 1 greater than 0. Then we know perfect square term positive or 0, no? Positive or 0. So when you put x equal 1, then that is 0. All the other cases that is positive. Therefore, for this case, the solution is real value, any real value, x element of real set minus and x not equal 1, no? So when we put x equal 1, that is 0. But here we need to get values for positive values only. Then any real value but x not equal 1. Then x minus 1 square greater than or equal 0 solution. Here when x equal 1 equal 0 satisfied, all the other cases positive. Then here any real value. Sixth one, x minus 1 square less than 0. So definitely this won't happen, no? When x equal 1 value 0, when x other than 1, then all the others are positive, no? Perfect square. Then this is, for this we don't have any real solutions. Seventh one, say x minus 1 square less than or equal 0. So for this case we don't have any negative value, perfect square means positive or 0. Then we have only 0 value, x equal 1 is the solution. Only x equal 1 is the solution. So that satisfies only equality, not inequality. Here x equal 1 is the solution. X equal 1 is the solution. So 7th, 8th one, consider x square plus 4 greater than 0. So here x square plus 1 definitely positive. Then for any real value of x, that is happen, no? Then any real value is possible. Any real value is possible. That's how we do. And there's another special thing. But I told you that one last day. But anyway, you revise it. Consider x squared plus x plus 1. X squared plus x plus 1. So here x plus complete square, 1 over 2 square, 1 minus 1 over 2 squared. Then x plus 1 over 2 squared, 3/4. Then here positive, and with this one that is completely positive, no? Therefore remember x square plus x plus 1 is positive relation. So when you see x square minus x plus 1, so we change only sign here, then x square minus x plus 1 also positive relation. Like x squared plus 1 positive relation. X square plus 1 positive relation, likewise x squared plus x plus 1 is a positive relation. X square minus x plus 1 also a positive relation. Positive relation. Okay, you at the beginning you put this note first, right? All put that note. Okay. Now let's do few advanced simplification, not that much advanced. We have to use complete score method. Okay. Now see this. So when you have factors, then no issues, no issues to evaluate an inequality, no. But when you don't have any proper factors, then we have to get complete score method, no. See, x squared plus 2x minus 1 greater than 0. Then here the way we put perfect square, we write x here, same sign plus x coefficient we divide by 2 and write here, and minus 1 and subtract square of this. Then x plus 1 square minus 1 square. Then x plus 1 square minus 2. Then for this case we write x plus 1 squared root 2 square like this. Now difference of 2 square pattern, x plus 1 minus root 2, x plus 1 plus root 2 greater than 0, no? So here we have minus, no? Then definitely we have factors. They are irrational factors. Then you write like difference of 2 squares, then factorize a minus b, a plus b. Then for evaluate this one, here this factor 0 value, x equal minus 1 plus root 2. Minus 1 plus root 2. And here factor 0 value, minus 1 minus root 2, no? So this factor 0 mean x plus 1 minus root 2 0, then x equal root 2 minus 1, here it is. And here this factor 0 mean x plus 1 plus root 2 0, x equal minus 1 minus root 2, here the value. Then start right hand upper corner and start sketching the graph, no? Then here we say plus, plus, minus, no equal here, no? Then positive region here and here, no? Then final answer x less than minus 1 plus minus 1 minus root 2 union x greater than minus 1 plus root 2. Here the solution, no? Usually we write x element of real set x such that within curly bracket. So likewise when we don't have any proper factors, we have to consider complete score method, no? Okay, do that example. Complete score procedure, ax squared plus bx plus c. First we have to take a outside from the bracket, x squared plus bx, b over ax plus c over a. Then here x perfect square, here put x, same sign plus, and here x coefficient you divide by 2. Don't put x here. Then when we expand this, we get x square and 2 times x times b over 2a, it is here, then b over 2a square, extra term, then c over a, that extra term you remove, b over 2a squared. Here complete square procedure. So previous case we have only one coefficient, no? Coefficient 1, and no need to worry about first step, then we can go to second step. Okay. Likewise, you have to get that relation. If you don't remember, better write. Huh? Okay. Now let's do another one. See this. Then here factorization very important. Consider x squared plus 4x minus 3 less than 0. Then here x square plus 4x, then write purpose square, then here x plus x coefficient you divide by 2, then we write 2 here, minus 3 and subtract square of this. Then write x, write plus sign, then x coefficient you divide by 2 and square of that you have to subtract. Then x plus 2 squared minus 3 minus 4 minus 7. You don't think here 2 square mean 4 minus outside. Okay? Minus outside. Here not minus 2 square plus 4. Okay. Then consider less than 0. Less than 0. Then here x plus 2 square minus root 7 square less than 0. Now it is like difference of 2 squares. X plus 2 minus root 7, x plus 2 plus root 7. Then here factor 0 value, 2 minus 2 plus root 7, and here factor 0 value, minus 2 minus root 7. Now you start sketching graph. Then here positive, negative, positive region. We need negative region. No? So if we have equal sign, then you have to shade this. Then final answer, x element of real set, x such that x in between minus 2 minus root 7 union less than or here minus 2 plus root 7. Here final answer. Okay, do that one. Do that. Okay, now do with me. 2x squared plus 3x minus 5 less greater than 0. Do with me. Then here x plus 3 over 2 squared minus 5 minus 3 over 2 squared greater than 0. Then x plus 3 over 2 squared minus 5 9 over 4 greater than 0. X plus 3 over 2 squared minus 29 over 4. Then x plus 3 over 2 squared root 29 over 2 squared. Now we can factorize it. No? Now we can factorize. Do with me. Then x plus 3 over 2 plus root 29 over 2. Difference of 2 squares. X plus 3 over 2 minus 29 root over 2 greater than 0. Now we can evaluate this. No? Now we can evaluate. Then you get factor 0 values. So 1 is here negative value. No? Minus 3 over 2 minus 29 root over 2. Then the other one minus 3 plus 29 root over 2. Let's write at once. 3 plus 29 root over 2. Then positive region here and here. No? Then x element of real set x such that x less than minus 3 plus 29 root divided by 2 union x greater than minus 3 plus 29 root divided by 2. Complete. Okay. Now let's move forward. Up to now we have discussed the things about polynomial inequalities, especially linear one and quadratic one. No? But further we can have further polynomials, degree 3, degree 4, degree 5, so on. No? Then to evaluate those type of inequalities, first step, you better take all terms into one side. Okay, you better take all terms into one side. So when you take in all terms into one side, you check the leading term first. That better to get positive. Okay, that is not must. Okay, but you better to get leading term as positive. That is very important. Thereafter you have to factorize it. Thereafter we can evaluate the inequality. Okay, write down this. When evaluating polynomial inequalities, take all terms into one side. Take all terms into one side. Take all terms into one side where the leading term is positive. Where the leading term is positive. Where the leading term is positive. And then factorize. And then factorize the expression. And then factorize the expression. Okay. Now say this, Anna. I'll do 2-3 examples. So I'll get factorized version, x minus 1, x minus 2, x plus 1 less than 0. Here take this example. Here this is cubic inequality, no? So anyway, all factors are given, all terms in one side, and the leading term is positive. So when you expand this, x cube term is positive term, no? Okay, here we evaluate this real number line. Here 0 value 1, mark it. Here 0 value 2, mark it. Here 0 value minus 1, mark it. Those are critical values. Then right hand upper corner, you start sketching the graph. Change sign, change. Likewise, you change it. Then this one we call positive region, this negative, negative. We don't have equality, then you remove these points. Then negative region, select negative region. Then final answer is the shaded region. X element of real set x such that x less than minus 1 union x in between 1 to 2. That's how we evaluate, okay? So at the very beginning, you have to take all terms into one side where the leading term is positive. Thereafter you have to factorize it, no? Factorize. But here all the things are given, leading term positive, all terms in one side, then no worries. All the factors are there. Then you take factor 0 values, start right hand corner and sketch the function. See another one. X plus 1, 2x minus 1, x minus 2 greater than or equal 0. Now when you expand leading term positive and all the factors are given, all terms in one side, then here real number line, here 0 value minus 1, mark it. Here 0 value half, 2x equal 1, x equal half. Here 0 value 2, no? We have equality here, then you shade this one. Then right hand upper corner, start sketching the graph like this. Then here positive, negative, negative. We need positive region here and here. Then final answer, x element of real set x such that x in between minus 1 to half with equal, no? Union, here two different regions, no? Then x greater than or equal to. That's how we do. Then very simple thing, evaluation of polynomial inequality, very simple thing. But you have to factorize the relation, then we can take it now. Okay, do these two examples. Now you try these questions. You have few questions. Try to complete them. Okay. All the relations factors are given. Then no worries, we can do at once. real number line. Here 0 values 1, 2, 3. 1, 2, 3. Start right hand corner. No equality, don't shade. Positive region needed. Here positive, positive, negative, negative. Then finally you write the answer. Finally you write the answer. Here x element of real set x such that x in between 1 to 2 union x greater than 3. Likewise you complete the solution. Then here 2x minus 1 0 value half, x plus 2 0 value minus 2, 3x minus 1 0 value 1/3. No? Then start right hand upper corner. Negative, negative, positive, positive. Here are the regions. Then here shaded region is the solution. Finally you write it. Here real number line 0 value 2. Here 0 value 4. 0 value here minus 3 over 2. We have equality. Then shade. Start right hand upper corner. Sketch the graph. Positive, positive, negative, negative. Need positive solutions. The shaded region is the solution. Finally you write answer. Real number line. Here 0 value 3 over 2. Here 0 value minus 5. And here 0 value 4/3. 4/3. 1 and 1/3, no? 1.33. 3 over 2, 1.5. Then 4/3 somewhere here. Likewise, you identify the relative positions, okay? Then do this, say negative, positive, negative, positive. Then negative region here and here. Then take this. So we have 4 factors, no? We have 4 factors here. Here 4 factors. Here 0 value 4. Here 0 value 3 over 2. Here 0 value minus 1/3. And here 0 value 0. Here we have 4 factors. Then that also you do right hand upper corner. You do this, say. Then here positive, 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 negative, negative. We need positive region. Here one region. Here another region. Here another region. We have 3 regions. We don't have equal here. Don't change. Then here real number line 0 value minus half. Here minus 1/3. And minus 1/4. We have equality, shade, shade, positive, positive, negative, negative. Need positive regions. Yeah, they. Continue. By the side you write down final solution, okay, like a set. Okay, ninth one. Here real number line. Here 0. Here 2. And here minus 3 over 2. Negative, positive, negative, positive. then negative region, and here. Finally write solution. The last one, here 4x minus 1, x plus 2, 2x minus 3, no? Then here 3 over 2, here minus 2, and here 1/4. So we have equal here shade, then negative region here and here, positive, positive, negative, and negative. That's the shader region is the answer. Okay, then that technique works for any number of factors. Okay, not only for 1, 2, 3, 4, whatever it is, okay, that will work. But there are some special things. There are some special things. We have discussed them. Okay, now you see here x 2x minus 1 greater than 0. So here we have one factor, sketch real number line. Here 0 value half. Start sketching graph like this. Here positive, negative. We need positive region. Here the solution. X greater than half is the solution. No? Okay. Further, this is linear. To evaluate that one, we can subject x. That is another algebraic method. Now, for two factors, 2x minus 1, x plus 1, we can follow same technique. Real number line, here 0 value half, and here 0 value minus 1. You do this way. Positive, positive, negative. Say greater than 0. Then we need positive region. Then here 1, 2, 3. X plus 1, 2x plus 1, x minus 2. Real number line, here 0 value 2, here 0 value minus half, and here 0 value minus 1, less than 0. We know the technique, no? You select negative regions. Positive, positive, negative, negative. Then when we have four factors, x into x minus 1, x minus 2, x minus 3, you follow same technique. Real number line, here 0, 1, 2, 3. 0, 1, 2, 3. Mark critical value, start sketching from the right hand upper corner. Then positive, 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 negative, negative, need positive, greater than 0 means positive region. Okay, we have three regions, no? No equality, then you remove these points. Then when we have x times x minus 1 times, x minus 2 times, x minus 3 times, x minus 4 kind of thing. Then we have 1, 2, 3, 4, 5 factors, no? 5 different linear factors. Then you follow same technique. Here 0, 1, 2, 3, 4. Start right hand upper corner. This way. Negative region. Here, here, and here. plus 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 minus minus minus. Now it's very simple technique. Then the major thing, we have to factorize it. Now we need to take all terms one side such that leading term is positive. Thereafter we have to factorize it. Then we can proceed. Then factorization is the important one. We have to practice it well. Okay, note them. Okay. Let's do another 2-3 examples. Okay, you better do with me. See x square minus 1, x minus 2, x plus 1, x plus 3 greater than 0. Check this one. So here we have to factorize this one. Then x minus 1, x plus 1, x minus 2, x plus 3 greater than 0. Now we can proceed. Now without factorizing we can't do. Definitely we have to factorize everything. Huh? Real number line. Here 0 value 1, 0 value 2, 0 value minus 1, 0 value minus 3. Start right and upper corner. Then positive regions here, here, here. Shade them. Then x element of real set. X such that x less than 3 minus 3 union. X in between minus 1 to plus 1 union x greater than 2. Okay. See, if you have x square plus 1, x minus 2, x plus 3 greater than 0. See this one all. Here x square plus 1. Previously x square minus 1, it has factors, no? But this case we don't have any factors, no? X square plus 1 we don't have factors. But we know here surely positive, no? It is positive relation. Completely positive relation. We know that sign. So here whole thing must be positive. This part positive. That means you have to filter only this part. So here take x minus 2 times x plus 3 greater than 0. Likewise, we have to filter it. Full thing must be positive. One part we know positive, then you have to filter other part. That must be positive, no? This is our inequality now. Now we know how to solve this. Real number line, here 0 value minus 3, here 0 value 2. Positive, positive, negative. Positive region is this. Then final answer, x element of real set, x such that x less than minus 3 union x greater than 2. Continue now. Okay. Then I'll give you a few questions to do. You try them. Now you try. You think and do. Take time. Try these questions. First, you clearly identify different factors. Then check whether those factors positive or negative. If you can discuss that signs, then you better to discuss it. Here this is positive, likewise other we don't know signs, no? Here this one positive. Then whole thing must be negative, then this is positive, then this must be negative, no? Likewise you filter it and finally get the answer. Take little time. See first, here third one, x square plus 4 positive. We know that is positive. Then whole thing must be negative, no? Whole thing must be negative. Then we know this is positive. Then you filter only this part. Then x plus 2 x plus b, x plus 3 must be less than 0. Likewise, you have to filter it. Then we can evaluate. No? Real number line, here 0 value minus 3 and here 0 value minus 2. Then start sketching the graph. We need negative region. Here it is. Here the region. Then by the side you write solution. By the side you write x in between minus 3 to minus 2. No? Then x square plus 9, x square plus 9 surely positive. Then whole thing must be negative. Then you have to filter this one. That is x plus 5, 3x minus 1 less than 0. Then real number line, here 0 value 1/3 and here 0 value minus 5. Then negative, here negative region. Finally we write answer. Then purpose square term, positive or 0, positive or 0, but here full thing must be positive, no? Full thing must be positive. So here you have to filter x plus 1 into x minus 3 greater than 0. Then here minus 1 plus 3. Then we have to select plus regions here and here. No? Then take this x minus 1 square positive, 2x minus 1 square positive, whole thing must be negative. Then we know this part, x minus 4 less than 0. Then the solution x less than 4. Likewise, you think about sign non-sign expressions. And further, x squared plus x plus 1, at the beginning I told you, this is positive relation. No? X squared plus x plus 1 positive relation. Then you have to take only these two factors, 3x minus 1, x minus 2 greater than 0. Then we know how to evaluate this. Here 0 value 1/3 and 2. Then here positive region and negative region. And see this, x squared plus 1 positive, x squared plus 4 positive, x squared plus x plus 1 positive, then whole thing must be positive. That means here this x must be positive. This is exactly positive, definitely positive, no? Then here x, that sign unknown, then we have to take that positive, then only full expression will become positive, no? Complete it. Okay, all these are inequations. So inequations has many solutions, no? Infinite solutions can be there. Then we can write on this solution set. Okay. Now while you are doing that, you see, as I remember I gave this, but anyway, x squared relation positive or 0. This can be positive or 0. Minus x square negative or 0. Then x minus 1 square, a positive or 0 possible. X minus 1 square, a negative or 0 possible. X square plus 1 positive only. X minus 1 square plus 2 positive only. Minus x square minus 1 negative only. Minus x minus 1 square minus 4 surely negative. Negative, okay. Then x square minus 1, here x square plus 1 positive, but x square minus 1 we can't say the sign, no? Can't say sign. We can't say sign, but here we can exactly say these relations are positive or 0, okay. Then perfect square can be positive or 0. So perfect square with minus sign outside, negative or 0, no? Negative or 0. Okay. Then x plus 1 squared minus 4. Because of this minus sign, we can't say it's sign. We can't say sign, no? Better note it. Better note that. Okay, now see this. Now see this example. Now this type of things we have to very carefully do equalities with equalities. Okay, check this one. X minus 1 squared into x plus 1 greater than or equal 0. So we have equality and inequality both, no? So we say greater than or equal. Here we can split this. X minus 1 square, x plus 1 greater than or equal. X minus 1 squared, x plus 1 equals 0. Here the thing, greater than and equal. O mean union and mean intersection. No? O mean union. Now we can evaluate this. Here positive, we know this part, positive or 0. And here positive region, we have to select only positive region. Then you consider only about x plus 1 greater than 0. X plus 1 greater than 0. And here you remember x not equal 1 for this case. For this one x not equal 1. Then evaluate this. X greater than minus 1. When x equal 1 we get 0 value. But for this inequality 1 not satisfied. O mean union, then for this equality x equal 1 possible, x equal minus 1 possible. X equal 1 possible, x equal minus 1 possible. Now union mean we have to consider all. We have to consider all. Union mean we have to consider all. Then sketch real number line. First you mark this. Minus 1. And here not equal 1. Here this is for inequality. This is for inequality, okay? For this part solution is that. But for equality we have 1 and minus 1. We have 1 and minus 1. Then O mean all together, no? Then full shaded region will be the answer. Full shaded region, that is greater than minus 1. No? Then x element of real set x such that x greater than or equal minus 1. Did you get it? Okay. When you have equal, greater than or equal thing, you separate inequality, separate equality, solve inequality, solve equality, gather them together. Okay. So we have to take all together. That is the important thing. Okay, do that example. You think Okay, you see another one. Identify these logics. Huh? See another one. Take x minus 1 squared, x plus 1, x minus 2 less than or equal 0. Okay. So we have equality and as well as equality, inequality. No? Both we have. Then you better to split it. Then x minus 1 squared, x plus 1, x minus 2 less than 0 or x minus 1 squared, x plus 1, x minus 2 equals 0. Then here equality solution x equal 1, minus 1 and 2. No? We have 3 solutions for equality. And for inequality, here this part positive was 0. No? Positive was 0, but we need to get negative values. Then for this one, when you put x equal 1, that we get 0 value. Then you remove that one, x not equal 1. When you put x equal 1, then this one satisfied. No? Forget it now. Now, and here x plus 1, x minus 2. So this is positive, then we can forget it, less than 0. Then we can evaluate minus 1, 2. Then positive, positive, negative. Here negative region. Or mean union. Now we have to take all together. Here O operation. Now sketch real number line. It's also real number line. First mark this region, minus 1, 2, here inner region. Here x equal 1 not there. Here 1 not there. Here this is for inequality. Now for equality, x equal minus 1 there and x equal 1 there and x equal 2 there. Then finally, for this inequation with equality, we can get the shaded region. No? We can get the shaded region. Then final answer, x element of real set, x such that x in between minus 1 to 2 with equal sign. Okay? Do it now. Okay, after that you do these 3 questions, analyze properly. Okay, check your answers. Here first one, x minus 2 squared, x square plus 1, x minus 1 greater than or equal 0. First you separate x minus 2 square, x square plus 1, x minus 1 greater than 0 or x minus 2 squared, x square plus 1, x minus 1 equals 0. Separate equality and inequality, no? Then easily we can solve equality, no? Then find solution for this. We have x equal 2, here we don't have solution, no? And x equal 1 we can get here. Operation mean union. Here this is completely positive, but here positive or 0. Then we don't have equality here, we have completely separated, no? Then we can't get 0 value, then definitely x not equal 2. And then positive, positive, here you take only this part. Then x not equal to and x greater than 1. Union x equal 1 and 2, no? X equal 1 and 2. Now mark them on same number line. X greater than 1. X not equal 2. But here x equal 1 and x equal 2. Then full final answer, full shaded region. X greater than or equal 1, no? Then that included x equal 2. Then greater than or equal 1, that's enough. Complete. Okay, then second one, here x plus 2 squared, 3x minus 1, x plus 1 less than or equal 0. See, x plus 2 squared, 3x minus 1, x plus 1 less than 0 or x plus 2 squared, 3x minus 1, x plus 1 equals 0. Likewise, separate equality and inequality. For this equality, we can get solution minus 2, 1/3 and minus 1. For this inequality, here positive was 0. But here negative, then we can't get 0 value. Then you take x not equal minus 2 and here full thing must be negative. You take only this. Union. So when we have equality, then we have to think lot. Huh? So we have inequality and equality, two different things. So we have to think equality, we have to think inequality. Thereafter we have to gather it. Now here less than mean minus 1, 1/3. Then here negative, positive, positive, negative region. Then mark inequality here. X not equal minus 2. Then minus 2 not included here. Then minus 1, 1/3. Then we need inner region. Then no worries about this. That is minus 2 outside this shaded region. Then no worries about that. But we have to get now minus 1, 1/3 and as well as x equal minus 2. So that is outside here. So that minus 2 comes with equality, okay, not with inequality, comes with equality. Then final answer, the shaded region. Then shaded region is here x element of real set x such that x in between -1 to 1/3 with equal sign and another -2 union x equal -2. Likewise, we have to completely write final answer. Okay. Check very carefully. Yeah? Check very carefully. Okay, then last one. See this, x square plus 1, x square minus 1, x minus 1, x minus 2 greater than or equal 0. Then we can factorize this, x minus 1, x plus 1. Further you write, then x square plus 1, we have two x minus 1 terms, no? Then x minus 1 square, x plus 1, x plus 2 greater than or equal 0. Then you separate equality and inequality. X square plus 1, x minus 1 squared, x plus 1, x plus 2 greater than 0, or your operation x square plus 1, x minus 1 squared, then x plus 1, x plus 2 equals 0. Then here solution x equal, here we don't have solution for this factor, and here 1, minus 1 and minus 2. We have three solutions for that. Then here completely positive, and here positive was 0. Then 0 value you exclude, you remove 1, because we need greater than 0 value. When you put x equal 1, that becomes 0. And here x plus 1, x plus 2 greater than 0. Here minus 2, minus 1, positive region here and here. Then x1 you have to remove, no? Then for this inequality, you have to take this shaded one. Then finally for full combined version, you do at once. Minus 2, minus 1, 1. Minus less than minus 2, greater than minus 1. This is for inequality, but with equality we can get 1, we can get minus 1, and we can get 2. Then finally shaded region solution. Shaded region is the solution. Then x element of real set x such that x less than or equal minus 2 union x greater than or equal minus 1. Minus 1. Plus 1 x minus 2, ne? X plus 1 x minus 2, minus 2, minus 2, then 1 minus 1 plus 2. So we had to reset it, no? Okay, check it. Here -1, 2, then here positive region, here positive region, then 1 exclude, no worries about that. Then finally include this. So both together -1, 1, 2, greater than or equal to, equal 1, less than or equal -1. Then x element of real set, x such that x less than or equal -1 union, x greater than or equal to union, x equal 1. You have to write, separate all things at once, okay? Okay, up to now we have done all the things about polynomial inequalities. Then later we can start rational inequalities, okay? Now you write new topic, rational inequalities. Write down new topic, rational inequalities. Rational inequalities. Okay, right? An inequality with rational function, an inequality with rational function is a rational inequality. Is a rational inequality. An inequality with rational function is a rational inequality. And an inequality with rational function is a rational inequality. When evaluating a rational inequality, when evaluating a rational inequality, when evaluating a rational inequality, use the following working rule. When evaluating a rational inequality, use the following working rule. When evaluating a rational inequality, use the following working rule. Use the following working rule. Step 1. Step 1. Take all terms into one side. Take all terms into one side. Take all terms into one side. Within bracket write down. Don't do cross multiplication for. Don't do cross multiplication. Don't do cross multiplication for unknown quantities, unknown quantities. Second one, take common denominator and completely factorize numerator and denominator. Take common denominator and completely factorize numerator and denominator. Completely factorize numerator and denominator such that the leading terms are positive. Thereafter evaluation can be done. Thereafter evaluation can be done. Put another star mark and write down. Denominator zeros must be excluded. From the beginning. Okay, so that's how we evaluate rational inequality. Yeah? So rational mean it has division of two polynomial, then it has denominator terms with x, no? Then those are we call rational functions. So with rational function we have inequality now. The procedure, we have to take all terms one side, but cross multiplication impossible. We have to take all terms into one side, get common denominator and simplify. And finally you factorize numerator and denominator. Thereafter we can evaluate. And the important thing, we have to remove denominator zeros. Okay, denominator zeros we have to eliminate. Okay, see example. 2 greater than x of x minus 1. Here this is rational type inequality. So you have to take all terms one side. So I'm going to take this one here. 2 minus x of x minus 1 greater than 0. Don't cross multiply, okay? For equalities you can cross multiply. We don't know sign here, no? Then we can't cross multiply. That is very important, no? But for equalities we can do, but for inequalities we can't. Okay? Then don't cross multiply, take into the other side. Now get common denominator. X minus 1, here 2, x minus 1 minus x greater than 0, 2x minus x minus 2 over x minus 1 greater than 0. Now here we have factors, no? Okay, we have factors. Now you have to eliminate denominator 0. Here x equal 1 impossible. Then x equal 1 impossible. You have to remove it. Now don't worry about this. We have denominator and numerator factors. Then you take zeros here like polynomial 1. Here 1 and here 2. Mark them on the number line. Now here whole thing must be positive. You do same method. Plus minus. Whole thing must be positive. Then one region here, another region here. Then x, element of real set x such that x less than 1 union x greater than 1. Okay, and that is very simple. So anyway, you especially remember cross multiplication impossible. We have to take all terms one side without cross multiplying, then simplify and factorize numerator and denominator. Okay, see another one. Question number 2. Example 2. 1 over x minus 1, 2 over x plus 1. Okay. I'll take this on the other side. 2 over x plus 1, 1 over x minus 1 less than 0. No? When we take this one, less than. Now get common denominator. X plus 1, x minus 1, cross multiply. 2 into x minus 1, minus 1 into x plus 1, less than 0, 2x minus xx, minus 2 minus 1 minus 3, x plus 1, x minus 1 less than 0. We have 3 factors now. So don't worry about denominator and numerators. So you think like polynomial now. Mark zeros here, 1, minus 1 and 3. Then you remove denominator zeros, minus 1 and 1. Minus 1 and 1 you remove, okay. So see, let's say you have equal to here. Equal to here. Then we have to exclude minus 1 and plus 1. You exclude them. But we have to include 3, no? Numerator zeros, okay. Only denominator zeros you have to exclude. Then you take numerator 0 only and denominator zeros you must exclude, okay. That because of that is in denominator. Now right hand upper corner, you start sketching function like this. Now here positive, positive, negative, negative. We need negative region, less than 0, negative, no? Here it is. Then final answer, x element of real set x such that x less than minus 1 union x in between 1 to 3 with equal 3, no? Okay. Then very simple thing. We have to take all terms into one side without cross multiply. But some cases we can cross multiply. Sign known thing we can cross multiply. No? Unsigned thing, here we don't know sign here. Then we can't cross multiply. Then you take all terms one side, get common denominator, simplify, factorize numerator and denominator. Thereafter we can evaluate. And again we have to remove denominator zeros. Here denominator 0, 1 and minus 1 we have to remove. Okay, do these examples. Okay. Now you do these questions. I'll give you simplified versions. You try alone. You do alone. So I have given here simplified versions. All terms one side, factors are given where the leading terms are positive. Then no need to think about lot, but when we have equalities, we have remove denominator zeros. No? That is the important thing. Continue. Okay, check your answers. Here 0, 1, 5, minus 1. Here minus 1, 1, 5. Don't have any equal here. Then negative region here and here. Minus, minus, plus, plus. Less than minus 1 in between 1 to 5. Finally, right answer. Then 2, 1, half. So equality for half only. We have equality here. No? Remove denominator zeros. Then positive, positive, negative, negative. Then final right answer here, equality only for half. Huh? Here 2, 1, half, 0, minus 2. Then 2 and half, we don't have equal. Then right hand upper corner, positive region, positive, positive, positive. We have 3 regions. Here, here, and here. Finally, right answer. Here 0 value 1 and minus 2, and here 0, 0, 1/3, 1, minus 2. Equality for 0 and 1/3. Denominator zeros, we don't have equality, no? Very carefully do that. Huh? The negative region here and here. Then equality for these two. No? Complete? Okay. Now take your worksheet. Take your worksheet. So we have done first 2 questions now. First one and second one we have done. Then move to question number 3. I'll give you order, you complete. Huh? I'll give you the order, you complete. Question number 3. Question number 3. 1, 4, 10, 9, 3, 6, 7. Sorry, 2. Okay, start doing. And 7. You better do 7 somewhere here. 7. Okay, take your time. So now we have to think all rational one. Don't go to cross multiplication, but you can do cross multiplication for sign on quantity. Okay, if you have positive thing, you can cross multiply, no, without changing the sign. If you have negative quantity, you can cross multiply, but you have to change the sign, no? You have to change the sign, but don't cross multiply unknown sign quantity. Okay, otherwise you have to take all terms one side and go previous procedure. Okay, I'll give you small time to do it. Take time. Okay, let's see few questions. 1, x square plus x plus 1 over x square plus 2 less than 1/3. 3 positive, we can cross multiply. X square plus 2 positive, we can cross multiply. Okay, x square plus 2 positive. Then that cross multiplication possible for this case. Then let's cross multiply. 3x square, 3x, 3, x square plus 2, take all one side, 2x square, 3x plus 1 less than 0, factorize. Now it is polynomial type inequality, no? Minus 1, minus half, the negative region here, then x, element of real set x such that x in between minus 1 to minus half within curly bracket. Then 4. 3 minus x minus 2 less than 4. Take this on the other side. Then get common denominator. Do simplification carefully. 4x, x, 5x, 8, 3, 11, x minus 2 greater than 0. Now we have two factors here. Two factors here. Here 0 value 2 and here 0 value 11 or 5. Then positive, we don't have equality. Then here the region. X element of real set x such that x less than 2 union x greater than 11 or 5. First two questions. Take it. Okay. Then seventh one. X plus 2, 3x minus 1 over 4x square minus 3x plus 1 less than or equal 0. The numerator factors are given. No? Then see whether we have factors in denominator. Here we don't have factors. No? 4x, x, 1, 1, we don't have factors. Change this sign. No? Change this sign minus. Then here minus plus. 4x square minus 3x minus 1. Now it is okay. Now here minus 2 minus 1/4, 1/3 and 1. We don't have equality. No? Denominator equalities we have removed. 1 and minus 1/4 and 1/3 possible, minus 2 possible. Then negative region here and here. X element of real set x such that minus 2 to minus 1/4 equal minus 2 union x in between 1/3 to 1 equal to for minus 2 and 1/3. Then question number 10. 10x over x square plus 9 less than or equal 1. Then here x square plus 9 positive, no, cross multiply. 10x x square plus 9. Identify when we can cross multiply and when we cannot. Likewise you identify. Yeah? Here this is positive, then we can cross multiply. Then x square minus 10x plus 9 greater than or equal 0. Factorize x 9 1 minus minus. So we have just polynomial inequality, no? 1 and 9. Then here positive region, x element of real set x such that x less than or equal 1 union x greater than or equal 9. Okay, continue. Okay, now sixth one, 11th one, x plus 3 over x minus 1 greater than x. Take this on the other side. X plus 3 over x minus 1 less than 0. Then take common denominator, cross multiply. Here need bracket. Then x square minus x minus 2x minus 3 x minus 1 less than 0. We have factor here. X 3 1 minus plus. Now here zeros, minus 1 1 3. Negative values here and here. Positive, negative, positive, negative. Therefore less than 0 here. X element of real set x such that x less than minus 1 union x 1 to 3. 1 to 3. Then question number 3. X plus 4 less than minus 2 over x plus 1. Take this here. X plus 4 plus 2 over x plus 1 less than 0. Get common denominator. Then here x square 4x x 5x 4 plus 2 6. Then factorize x 3 2 plus plus x plus 1 less than 0. Minus 3 minus 2 minus 1. We don't have equality now. We don't have equality. Then negative region here and here. Then x element of real set x such that x less than minus 3 union x in between minus 2 to minus 1. That is third one. Okay, then sixth one, x minus 1 squared over x plus 5 less than 1, we can't cross multiply. X minus 1 square over x plus 5, take 1 the other side. Here x square minus 2x plus 1 minus x minus 5 x plus 5. Then x square minus 3x minus 4 x plus 5 x 4 1 minus plus. Now here we have factors. Now we can evaluate it. Minus 5 minus 1 4. Negative region here and here. Real number line, no equality. Final answer, x element of real set x such that x less than minus 5 union x in between minus 1 to 4. X in between minus 1 to 4. Continue. Then second one, x minus 1 over 3x plus 4 less than x minus 3 over 4x minus 3. Take this on the other side. X minus 1 3x plus 4 x minus 3 4x minus 3 less than 0. Get common denominator. 3x plus 4 4x minus 3 cross multiply. x minus 1, 4x minus 3, x minus 3, 3x plus 4, 4x square, minus 3x, 4x minus 7x plus 3 minus 3x squared, 4x, 9x minus 2x, sorry, minus 5x minus 12, 3x plus 4, 4x minus 3. Okay. Then 4x squared, 3x squared, x squared, 7x, 5x minus 2x, 3, 12, 15, 3x plus 4, 4x minus 3 less than 0. Now denominator we have factors, but for numerator we don't have, no? So here we don't have proper factors. Then you have to check with complete square, no? You have to check it with complete square. Okay, get complete square. Here x square minus 2x means x minus 1 squared, 15 minus 1 squared, 3x plus 4, 4x minus 3 less than 0. Then here x minus 1 square plus 14, 3x plus 4, 4x minus 3 less than 0. Now here numerator positive, no? Purpose square plus constant term positive. Then you take only denominator, 3x plus 4, 4x minus 3 less than 0. Real number line zeros. Here minus 4/3 and 3/4. Negative region is here. We don't have equality. Minus 4/3 to 3/4. Complete. Okay, now you mark these questions and do at home. You complete remaining question in question number 3, okay? You complete remaining questions in question number 3. Then question number 6. Do up to first 14 question. Do up to first 14 question. Then page number 4, question number 24 first one, 24 first one, 27, 28, 29, sorry, not 29, 27, 28, 30. 27, 28, 30. You can complete. Now, rational inequality part all over. Then we can move to modulus inequality. Then for your A-level question, there will be modulus part. Okay. Then next day we can start it. Then within 1-2 days, definitely we can complete that part. Okay, that's all for inequalities part for today.